before we move on to blasting, we just go to overview what is the rock handling. So it again, in four phases, we have to loose, load, haul, and compact, and with different equipment and method used. And like I say, we focus on the rock with have a hardness level in more scale 5 or above. So we need to drill and blast. In the previous one, we understand how to drill and different pattern. I just quickly review and move to the blast in here. So drilling pattern, as you can see, we have the principle. If you want a small rock particle, then you draw a small hole, small diameter, and close space between the drill, the hole. If you want a bigger particle of rock, then bigger diameter, but widely space between the drill. And there are two typical drilling pattern, rectangular and staggered, as shown, and the equation and the look at previous video to determine the volume of each hole and the volume of each linear foot of drilling in problem 2 that you have. So with that here, in the book also have a table that show you the process of handling for the rock, loosen, load, hold. If it combine load and hold, then what type of equipment and process involved. I don't have to repeat that. We talked that in the just previous video with applied to problem 2. And move to the if we use rectangular drilling pattern, and as you can see the diameter, the whole diameter, and then depends on the rock type. It is something strong rock like igneous rock, granite, basalt. Then as you can see, you need to use we need to use smaller diameter. It will use spacing even have closer, because it's too hard and you have to closer. It will take more time to drill, more labor, more material, explosive, etc. involved. If it with rock like a sandstone shell, basically that is a sedimentary rock, so you can have a loose space. And if you increase the diameter, then you need to have the space different as well. So that is the suggested typical drill hole spacing given the time of rock, 3 time of rock that we learned, and then the hole diameter. So now really move on to blasting. And for blasting, go back to here, when it blasting, it involve not only the equipment, but it also involve the material. So what are the material used for blasting? So first is the explosive and detonators. So explosive, it can use dynamite, ammonium nitrate, NH4NO3. So jobs you study fundamental of environmental engineering, especially you guys in dual major civil environmental engineering, you are expert in those kind of chemicals. And then we have ammonium nitrate in fuel oil, NFO, ANFO, and then slurries. And as you can see also other time of explosive, and you can see a recent blast in Beirut, Lebanon, that killed hundreds of people and with thousands of people wounded in the Middle East. That you see the how powerful of the explosive is. But here we use for the civil purpose. And as you can see, if you go to east of Aleppo, and some of you study civil material, maybe you have a field trip to the quarry, the rock quarry, mining quarry in the east of Aleppo. And to have that, we need to have a detonator. Basically, there can be classified in 2 types, electric or non-electric caps. In this class, we focus on electric blasting, EB caps, because it's widely used to have. And for blasting, it will create a vibration. Surrounding building maybe have some vibrate. So those are the 2 materials we need to do the blasting. So drill, make a hole, put the explosive in, detonator, and then use electric blasting to ignite, and then it will explode and give you the rock you want. So how to set up? Basically, electric blasting set up with the circuit, and there are three ways. First is series, parallel, or parallel series circuit. What is that about? The next slide here will show you that is the configuration for different type of circles. This, the first one, top, it show the series circle. So as you can see the caps, in this case 5 caps in one series, that we call it series circle. And for any given circle, they have three different resistance. The first one is the cap have a resistance, and then the connecting wire or bus wire also have a resistance, and the firing line go from the power source to the connecting wire, or from connecting wire to the power source, that is firing line. So those form the three resistance that we are going to analyze next. And then similar for the parallel circuit, as you can see, only one cap per branch, and in this case we have 5 branches, so that in a parallel, that we call parallel circuits. In real life, because you have, for example, make a grid of different holes for the drill, and then we typically use parallel series circles. So in this case we have 3 caps per branch, and that is one series, and we have 5 branches, that 5 parallels, so that is combined parallel and series circuits. So how to analyze, to determine the total resistance, to determine the minimum current requirement, and determine the voltage. So we have 6 steps in plastic circuit analysis. Some of you may be new in physics for this area, electrical, but that is good to learn, and that also good to review if you have learned that already. So to determine that, we first to determine the resistance of the cap circuit, and then so basically get the resistance of the cap circuits, and then we determine the resistance of bus wire and connecting wire, so that one connecting wire, and we determine the resistance of firing line, so from the power source to the connecting wire, or connecting wire to power source. This is a firing line, and it the same apply for other type of circuit. And when you have those 3, you can go to step 4 to compute the total circuit resistance, basically add those already determined in the first 3 steps, and then we determine the minimum total current requirement for the whole circuit. How to do that I will talk in the next slides. And then we solve for the required power voltage, use the Ohm law, or if we already know the power source, which means that we know the voltage, then we can solve for the current, and that current use Ohm law, and then we compare with the value in step 5, which is the minimum current requirement. If it the one to find out it less than the minimum current requirement, then it's not enough to do the explosion, so we have to put to the minimum power, improve the power source. So let's talk in detail how to get the resistance, how to get the minimum total current requirement. So the first one is table 65 in your book, and that is determine the minimum current requirement, and it depends on several parameters. The first is the time of circuit, that we just, if only one single cap, that easy. If it's series, the first one we show in the previous slides, parallel or parallel series, and it depends on the condition, normal condition, so it means no leak. And if leakage, if the power etc have some leakage, and then depend on the power source. DC stand for direct current, so it's only one way, and then AC alternating current. The current can change direction, just like the light here, power here we have. The battery is direct current, DC. With that, we have the minimum current for each series, for each cap. It depends on, so it's very important, we need to use the unit that they specify correctly to determine the step number 5 in here, minimum total current requirement. To determine the cap circuit, connecting wire, firelight, that go to table 6 and 6.7. this is 6 representative resistance of electric blasting caps. And if it leg wire, and that is the length of the leg wire, and in term of feet and in term of the meter, and you can get the nominal resistance for that cap. So that is solve the first step, the resistance of electric blasting caps. The second one is we want to find out, the second and the third one, we want to find out the resistance of the connecting wire or bus wire and the firing line. So that go to the table 6-7, and normally use copper wire, and it depends on the number divided by here, just like steel rebar, also number is also the number here, American wire gauge number. So when you have that, you can determine the resistance, but per 1000 linear feet or 305 meter. So that one is not ohms, but ohm per 1000 feet. So the step may be involved. We need to determine the how many linear feet I need for this bus wire, how many linear feet I need for the firing line. So that need to be done before we go to this table and find out the resistance. And when you have those three, you add them up, find out the total resistance. So with that one, we can go to the next video to apply to problem 3 to determine the total resistance of the electric blasting circuit, to determine the minimum current requirement, and then the voltage. And then the last video will show you how to combine all the lessons we learned to determine the hourly production of the drilling and blasting and the unit cost of rock excavation.